Hello, today I'm going to start section 8.3, Factoring Quadratic Expressions. The objectives of this section are to factor quadratic expressions by common factors, factor by grouping, special products, and AC factorization. In this section, we will look at different techniques and strategies for factoring quadratic expressions. Recall that factoring is the process of rewriting a number or expression as a product of smaller numbers or simpler expressions. Part 1. Common factors. Pulling out a common factor is the simplest type of factoring and involves using the distributive property in reverse. For example, A times B plus A times C is the same as A times B plus C. So you factored the original expression into the product of two simpler expressions. Example 1. Pull out the largest common factor from each of the expressions below. A. 4x squared minus 2x. Well, they both have an x, so I'm going to factor an x out. And then they both have a 2, so I'm going to factor a 2 out. Well, 2x times what equals 4x squared? 2x. And then 2x times what equals 2x? 1. So you get 2x times 2x minus 1. Now, until you get used to this, I do recommend redistributing just to make sure it works. Okay. B. 12x to the fourth minus 4x cubed plus 16x squared. Well, here, the smallest x is x squared, so they all have at least an x squared in it. And then 12, 4, and 16 all have a 4 in common. So when we factor out the 4x squared, we're left with 3x squared minus x plus 4. C. X squared times x minus 3 plus 4 times x minus 3. So here, there's these two terms. Now, these terms are not monomials, so that's why they look a little different, but they still are just terms. And if you notice, each of the terms have an x minus 3 in them. So what you can do is you can factor that x minus 3 out, and then when you do that, you're left over with x squared plus 4. Now, this last one is going to come in handy for the next section, factor by grouping. The process of factor by grouping is separate the terms into the sum of two groups, usually pairs. Pull out a common factor from each group. One or both may be negative. Pull out a large common factor, a binomial, of the form ax plus or minus b. Factor by grouping is usually applied to an expression with 4 or more terms. Factor each polynomial by using the factoring by grouping. So x to the fifth plus 2x cubed plus x squared plus 2. So I want to separate them into two groups. So let's do x to the fifth plus 2x squared for the first group, and x squared plus 2 for the second group. Now, x to the fifth plus 2x cubed, they have an x cubed in common, so I'm going to factor an x cubed only out of the first two terms. So then that's x squared plus 2. Now, x squared plus 2, they don't have a variable in common, and they don't have any coefficients in common. So the GCF is 1. So I'm going to factor 1 out. Well, when you factor 1 out, it doesn't change anything, but I still recommend writing it because it makes this next step easier. Because now I need to pull out the large common factor, the binomial, which is x squared plus 2. So I pull out the x squared plus 2, and then we're left with x cubed plus 1. B. 2x cubed minus 6x squared minus 3x plus 9. I'm going to group it, the 2x cubed minus 6x squared together, and the negative 3x plus 9 together. Then, just because subtraction is the same thing as adding the negative, I'm going to add a little plus sign there for me. Okay, the first two terms, well, they have an x squared in common, and then 2 and 6 have a 2 in common. When you factor that out, you get x minus 3. Now, this is an unwritten rule for factoring by grouping, but our next group is negative 3x plus 9. Because the first term is negative, you should factor a negative out. So I'm actually going to factor out a negative 3. Well, negative 3 times what is negative 3x? X. Negative 3 times what is positive 9? Well, negative 3. Well, now the x minus 3's match. So then I can factor the x minus 3 out. And then we're left over with 2x squared minus 3. C, x cubed plus 2x squared minus x minus 2. So again, I'm going to group it like this. And this with the little plus sign in between. So the first, x cubed plus 2x squared, we can take an x squared out. We're left with x plus 2. And then the second one, we can take a negative 1 out. And we're left with x plus 2. Then we can take the x plus 2 out. And then we're left with x squared minus 1. So that's how you factor by grouping. Now, sometimes you'll have 4 terms and it's not factorable by grouping. You'll notice this when the two binomials that you get in the second step don't match. Now, that doesn't automatically mean it's not factorable by grouping. Sometimes you do have to swap the middle two terms first, then it'll be factorable by grouping. Just an FYI. Part 3, factoring trinomials into binomial factors. We will often need to factor a quadratic trinomial of the form ax squared plus bx plus c into a product of two binomials. While there are a few strategies for factoring such trinomials, we will start by learning the AC factorization method. The process is illustrated below. Step 1. Find the product of the leading coefficient in the constant term, so a times c. List all the factor pairs of a times c, including signs. Choose the factor pair whose sum is equal to the linear coefficient b. Split the linear term bx into the two pieces according to the chosen factor pair, and then factor by grouping. If you've done steps 1 through 4 correct, it will always work. Example 3. Perform AC factorization for each of the following trinomials. Pay attention to the effect of the sign. So the first step is a times c. So a times c is 1 times 6. Then you need all your factor pairs. So what numbers multiply to 6? Well, 1 times 6 multiplies to 6. 2 times 3 multiplies to 6. But don't forget that negative 1 and negative 6 also multiplies to 6. And negative 2 and negative 3 also multiply to 6. Now, look at your factor pairs and see which of them add up to the middle term, 5. Well, this adds up to 7. This adds up to 5. So there's the ones we want. Next, you split that middle term into those two numbers. So it becomes x squared plus 2x plus 3x plus 6. So see, we started with a 5x, but it's split into 2x and 3x from our factor pair. Now group it. X squared plus 2x has an x in common. 3x plus 6 has a 3 in common. And then x plus 2, they have an x plus 2 in common, so we get x plus 2 times x plus 3. And that's how you can factor x squared plus 5x plus 6. Okay, x squared plus 3x minus 10. So a times c, which is 1 times negative 10, which is negative 10. So then your factor pairs, of course, we have 1 and negative 10, 2 and negative 5. Then we have negative 1 and positive 10, and negative 2 and positive 5. And then you add them up again to see which add up to positive 3. So we get negative 9, negative 3, oh, that's close, 9, and then we get 3. So we're going to use this last factor pair. So then it becomes x squared minus 2x plus 5x minus 10. And again, that's because negative 2x plus 5x gives us the positive 3x. Okay, grouping x squared minus 2x together, and then 5x minus 10 together. X squared minus 2x, well, they have an x in common. Then we get x minus 2. 5x minus 10 has a 5 in common, and then we also get x minus 2. So then we can factor out the x minus 2, and then we're left over with x plus 5. And then the last one, 4x squared minus 5x minus 6. So a times c is 4 times negative 6, which is negative 24. This one's going to have quite a few factor pairs. So you have 1 and negative 24, 2 and negative 12, 3 and negative 8, 4 and negative 6. But then you also have, I'm not going to have room to write them all out. Well, I'll write them over here. Negative 1 and 24, negative 2 and 12, negative 3 and 8, negative 4 and 6. And then you add them together. So 1 and negative 24 is negative 23. 2 and negative 12 is negative 10. 3 and negative 8 is negative 5. That's the one we were looking for. So I can quit looking. So then it becomes 4x squared plus 3x minus 8x minus 6. Group it again. Four x squared plus 3x has an x in common, so then we get 4x plus 3. Negative 8x minus 6, well, that has a 2 in common, but remember, since that first term is negative, we're going to take out a negative 2. And we get 4x plus 3. And then we can take the 4x plus 3 out times the x minus 2. Now, the reason why this third example is very good to do is you might have started noticing a pattern that it factored into the factor pairs that we got. So like we got 2 and 3, it factored into x plus 2x plus 3. We got negative 2 and 5, it factored into x minus 2x plus 5. That only happens when the leading coefficient is a 1. So if the leading coefficient is a 1, you can kind of skip the grouping part and skip straight to the answer. But if the leading coefficient is not a 1, as you can see, this did not factor into x plus 3x minus 8. We got something totally different. So you have to go through the entire grouping process to get the final answer. Then, I did say pay attention to the sign, because you don't have to write out all the factor pairs necessarily. Like for the first one, since they multiplied to a positive number, they're either both positive or both negative. But since I'm looking for when they add up to a positive, that means they're both positive. So I didn't have to write these two at all. For the second one, it's a negative, so that means one's negative, one's positive. But since it adds up to a positive 3, that means the positive number has to be bigger. So these first two factor pairs I didn't have to do because the negative number was bigger. And then here, where it multiplies to a negative, so one's positive, one's negative, but it adds up to a negative, that means the negative number has to be bigger. So I realistically didn't have to write these 4 pairs. And the only combination we didn't talk about is if the constant term is positive, that means they're either both positive or both negative. But if b is negative, that means they both have to be negative. So using those tricks will help you cut the number of factor pairs you find in half. Note, assuming the coefficients a, b, and c are integers, AC factorization can only dead end. There is no valid factor pair when the trinomial cannot be factored at all. So if the AC method doesn't get you an answer, that means it cannot be factored. 4. Factoring special forms. Recall from the previous section that there are a handful of special products. In fact, those same relations are also special factoring formats if used in reverse. So actually, let's write those out. So the first one was the square of a binomial, and that was when we had u squared plus 2uv plus v squared. That equaled u plus v squared. Or similarly, if you had u squared minus 2uv plus v squared, that was u minus v squared. Then you had your difference of squares, u squared minus v squared. That came from u minus v times u plus v. Then you had your difference of cubes, u cubed minus v cubed. Well, that was u minus v times u squared plus uv plus v squared. So let me put bullets here. And then finally, you had your sum of cubes, u cubed plus v cubed equaled u plus v times u squared minus uv plus v squared. So we're going to be using these, and I wrote them in reverse order from how they were in the last section because that's the way we're going to be using them in this section. So example 4, factor completely. 9x squared minus 121. Well, 9 is 3 squared. So this is 3 squared x squared. And 11 squared is 121. And remember, with exponent properties, I can rewrite this as 3x squared minus 11 squared. So this is a difference of squares. So by my difference of squares property, this must be 3x minus 11 times 3x plus 11. Okay. B. 27x cubed minus 1. Well, 27 is 3 cubed. And 1 is 1 cubed. Well, again, using exponent properties, I can rewrite this as 3x quantity cubed. Well, this is a difference of cubes. So, by the difference of cubes formula, this will be 3x minus 1. Then we have u squared, so 3x squared plus 3x times 1 plus 1 squared. And then simplifying that, you get 9x squared plus 3x plus 1. C. 3x squared plus 75. Actually, because 3 times 25 is 75, I'm going to factor out the GCF first. So even though we're on special products, don't forget all the other factoring techniques we learned. So this factors into 3 times x squared plus 25. Well, I know 25 is 5 squared, so this looks like a sum of squares. We actually can't factor it. There's no way to factor a sum of squares, so we are finished with C. D. Now, since D is a trinomial, you can use the AC factoring method if you want. But since it's a special trinomial, you could factor using one of these special rules. I'm going to show you that way, but again, if you prefer the AC method, do it that way. For example, I know 4x squared is the same thing as 2x squared. 9 is the same thing as 3 squared. And then 12 is the same thing as negative 2 times 2x times 3. So this is the square of a binomial. So this will, because of the minus sign, factor into 2x minus 3 squared because it fits this form. General guidelines for factoring polynomials. We will often want to use more than one of the above strategies to factor a quadratic expression. The following will help us progress through our methods in the most efficient manner. Factor out any common factors. Use the GCF. Factor trinomials using the AC method or a special formula. Factor polynomials with 4 or more terms by grouping. Check to see if any of the new factors can be factored further and use steps 1 through 3 for each. And that is it for section 8.3.